Assalamualaikum everyone, my name is Alya SAHARUDIN. So I want to present about PHY568, the electromagnetism and vector fields. And in this presentation, I will explain about the summary of chapter 1 until chapter 5. So what is electromagnetism? So electromagnetism studies how charges and magnetic fields interact. Stationary charge create electric field, moving charge generate magnetic fields. When these fields change over time, they induce one another, forming electromagnetic waves. Core concepts like charge repel, opposite attract, magnetic poles behave similarly. Magnetic fields line form loops. EM radiation such as light arises from oscillating electric and magnetic field. Understanding this basic is essential to electromagnetism. Now we go to chapter 1. So chapter 1, we will learn about electromagnetic model. Electric field originate from stationary charge and magnetic field from moving charge or currents. Static field remain constant in time. When field vary with time, they become coupled and propagate as EM wave. For the nature of charge, um, charge is conserved and quantized. It exists in units of elementary charge, where it's 1.602 times 10 power of negative 19 coulombs. All charged particles carry integer multiples of this value. Charge is the source of electric fields. For the Coulomb's law gives the electrostatic force between 2 point charge. The force increases with the charge and decreases with the distance squared. This describe the interaction of charge in vacuum. For the electric field is the force per unit charge. It shows how a positive test charge will behave in space. The field points outward from positive charge and inward to a negative one. For the electric flux is the amount of electric field passing through a surface. This is essential to Gauss' law and helps relate electric field to charge distribution. Electric flux density accounts for the medium. It represents how electric fields interact with the materials, such as insulator and dielectric. For the magnetic field, magnetic field basics. Fields are created by current or magnets. Field line loops from north to south outside and return inside. Flux density is measured in Tesla. For the solenoid is a coil of current-carrying wire. It produces nearly uniform magnetic field inside. The direction of the field follows the right-hand rule. Now we move on to electromagnetic wave. EM wave arises from changing electric and magnetic field. They travel perpendicularly to both fields. This wave carry energy and can propagate through vacuum. For the EM wave properties, speed of light where is 3 times 10 power of 8 and energy of photon visible of light has wavelength from 350 to 700 nanometers. All electromagnetic wave travels at light speed in vacuum. Now we move on to Maxwell equation. First, Gauss law is the divergence of E equals to charge density over permittivity. Fields lines start on positive charge and end on negative one. Then, for the no-magnetic monopoles, this means magnetic fields lines are always continuous loop. No single north or south magnetic pole has ever been observed. And for this law, a changing magnetic field induces a circulating electric field. This is the principle behind electromagnetic induction. For the Ampere-Maxwell law, a magnetic field is produced by electric current and also by changing electric field. This completed Maxwell symmetry. Now we go to chapter 2. In chapter 2, we will learn about vector algebra and coordinate systems, which is vectors and scalar. Scalar has magnitudes only, while vectors have both magnitude and direction. E and B fields are vectors and must be treated in with vectors method. For the vector operation, there is two product, which is dot product. The dot product gives a scalar. It shows how aligned two vectors are and is used in flux and word calculation. And cross product is where the result is a vector perpendicular to both